Okay, checking audio. 1, 2, 3. Good. Okay. I have about 1 million buffers open, as you can see. So I think we need to kill some buffers. We've got to switch over our project. So we can kill shell. Kill those. These are. Oh, yes. This is all the stuff from the old game development we were doing yesterday. Where we got some pretty good progress done. Skip scratch. That can stay. Actually, just about at the point in the game development where the technology is all there almost. We're just building up replay. That's like the last piece of technology. Then it's high scores. And then, yeah, basically art, a few more animations and audio to be added. So we are getting there, getting close, which is good because my estimate was 3 to 6 months, and we're just about coming up to the 3-month mark. So if we can have all the tech and most of the gameplay done by the 3-month mark, that will be a pretty good place to be. We're also down to the already got back trees. Okay, there, cleaned up our workspace. All right, here we go. We're going to do compilers today. We started last time. Let's go ahead and pull that up. DB documentation journal. So last time we outputted some text in our Tokenizer generator. And that is a text buffer, so it'll load files where we can send text from some other source and process that text. So that's basically where we left off. Got the DFA from the NFA. We're outputting text buffers. So 0830, oh my goodness. Let's get tasks and notes. So our tasks, let's steal those from the to-do list. What do we got going on here? We're going to get a character reference and a string reference today. That's the item on the list today. This context, we need to think through this just a little bit. So we'll do a little design around that. Once we have that context generated, we'll be down to generating the DF8 state table. And there's going to be several different methods we're going to use. But if we can grind through all of this in another, I don't know, 2, 3, 4 weeks maybe, which, I know it's 1 day a week. Like, really, this shouldn't take long if I was working on this more full time, but this is our change of pace project. Then we'd be in pretty good shape for the Tokenizer generator, although we're going to extend it quite a bit. Tokenizer generator with multiple locks. We'll talk about this conceptually when we get to it. Needs to we need to be using our own generated tokenizer. That's an item, and we will talk about these several methods that we want to generate things in for performance comparisons when we get there. So context. Okay, so we're gonna start with this. Starting out simple. Get a shell up. And do we remember what we were doing? Last time we were doing .source builds debug VV. Let's just look at our help options here. We were outputting. Actually, I think. Okay, come on. There we go. We were outputting. We had a test option. Basically looks like this. Okay, so we were already outputting VV test parser, which is very small. And we only, oh yeah, forward declaring that didn't matter here. Because VV test parser .c has these things for text processing, opening files. There's 3 different versions of file opening this. And this is the end of the TxtBuf class. We need to do character reference output, string reference output. There's the end of the namespace. Then in test.cpp is where we cheated to get access to this text buffer. So that's where we were at. We go to here. We opened up the file test billionv project, where it generated a VV test parser. And those aren't actually happening. So then makefile, where did we output that to? It is in builds debug. Okay. Hello world. Okay. So there we are. Now we need, just for a refresher on where we are. So we're taking files like this, where we say, here's the name of our project that we're going to tokenize and parse eventually. Our encoding is going to be ASCII in this case. And here's where we get our tokenizer definition from. I don't think we're doing anything with that right now. So then if we look at test.v tokenizer, we basically have a token name, the list of actions it can do. So X means we discard it, K means we keep it, and L means mark a new line in our code so that when we generate errors, we can point you to which line of code is the error. We ignore white space, we ignore comments. There we go. All right, so into source VV project.h. We're writing a bunch of these little write file helper methods, which if I remember right, is in VB project writing. Write CPP includes write text buffer, which is a static. It's just straight up one single string write. So nothing interesting there. Character reference here, it's going to get 3 different versions. So let's get started. A lot of it will be similar or overlapped, actually. So I have to decide. We can have 3. Okay, so writer point to write a line. We want to, well, let's see here. We'll have some private members. Not a new like character. Those are things we will have. And what's going to happen here is in VB project.h, we have an encoding. So our character reference has to be tailored to our encoding. So we have hand jammed our own UTF8 character handler here. This is the first thing we're going to do. But this is not at all similar to other things we will generate. So let's put some more includes in here. Standard int and CAssert are just useful everywhere. So is CString. TxtBuf specifically needs file handling, and character reference doesn't need any of that. This much is still common, so if I get this right, this will output the same thing for all of the versions. Then we have to do the thing. So we're going to VB project.h. We will switch on our encoding. And this is going to be a pattern you're going to see throughout this file. If we go to project encoding we're going to use ASCII break. So you have to generate different error codes depending on whether it's ASCII or was it Latin1 or UTF8. These errors we can steal straight up from here. Okay, Latin1. Oh. Good afternoon, Trevest. I'm good. Good. We're doing compilers here, so that always makes me happy. I like compilers. Text processing, transformations, state tables. Always good times. How are you doing? How are things in Sweden? One doesn't actually need these invalid reasons. But ASCII does. Guess we can do it that way. This one is none uninitialized. I don't remember. Oh, wait. Uninitialized end of buffer. Okay, so those are actually shareable. We do need those. These first three, I think, are just straight up stealable. Common. ASCII invalid byte. I think that's the end of that. Latin1 doesn't need any more. This thing goes to 5. Oops. So we could do it this way, where is that readable? Is this getting too convoluted? It might be just too convoluted. We do it like this. It's just easier to see what's going on. Problem is, we have to make our code readable both when we write it and when we read it. I'm good as well, thanks. Things are pretty good. Been a little cooler today. That's good. Yeah, we're supposed to be back up in, let's see here, I need to do some math here. We're supposed to be back up in the 90s tomorrow, so In Celsius, that would be, yeah, 32. It's supposed to be up over 32 tomorrow, so our nice cool fall is going to take a break. Latin1, the only thing it can do is those. UTF8 has all of these. I think this is more readable from the point of view of I need it to be readable here in this code file and in the file that's generated. So I think that's what we're going to do. It's a little bit duplicated. Like this uninitialized and end of buffer are common character states between all three encodings, but we're going to roll with it. Put a blank line after an enumeration declaration. Okay, so that's not too bad. Next thing, we need constructors and destructors for all of these. And this will look the same almost regardless. So, so these are not going to be called UTF8 character references. They will just be character references. For one, I want to add a note. Let's see here. File writer does write line. Oh, it does take format. Good. So we're going to put in a comment. 3, 4. Supported encoding is something which we will get from our VB project. I think we have an encoding name. Yes. So VB project encoding name of m_encoding. There we go. That way it's never in doubt what encoding we support in our generated code. Okay, so these got cleaned up. That's going to get cleaned up. That's nice and easy. Easy. Okay, let me just write this block out as is. 1, 2, 3, 4. Go again with the quote. Oh, we got the bots already. Yeah, the AI did a lot of BS, didn't it? Yeah, anytime somebody starts using std any and that kind of like coding pattern, I'm like, wait, do you not know what your system is supposed to be? Like you're trying to code for everything. And yeah, exactly. And honestly, you only had like what 5 mathematical operators that it was trying to be a variant over. It's like why don't you just either have a common base class and some virtual functions, which isn't my favorite way of doing things, but or make it a tagged union. Like why are we overthinking this? Put a switch statement and be done. Nobody understands what an std any like. It doesn't tell me anything about the code. So yeah, I saw that. I was like, wow. But you're learning a lot about the data sets that your AI was trained on. And we have to remember we're actually going to generate all the code in place. We're not doing a header file. There's no header files here. Length line after every one. Okay, what else do we need? UTF8 character reference. Most of this we don't need, but we will take equals. Will we take those equals? I don't think we care about any of those other comparison operators. So let's grab that. We do want advance. We do not need, I think, value or... Okay, these depend on several things. So this is more specific. 2C string. That will always be a thing, I guess. Will it? We might not. We've got some options. Invalid reason. Reason string. Perfect. All that's going in there. In private, we do want clear and update. That will be useful. I'm just stubbing things out right now. We're going to generate a lot of code. That's how I can definitely tell you're a decent programmer. You saw the first thing I did when I pasted the code. Like, oh yeah. Yep. I mean, I'm trying to think if there's a time when I would be like, yeah, use any. It's a great thing. I just can't think of that many. Maybe in like some weird plugin that supports all sorts of nonsensical anything that anybody ever wants to write, but well. Oh well. Okay. This one is just going to be a character reference. Can I already do assignment operator? That's this one. It's a lax use case. You really don't use any unless you don't care. Yeah, exactly. And I care. I care a lot. I'm a very caring individual. Assignment isn't too bad. These two, I think, can be almost shared. I think these will depend on what we want to do here. Then let's see here. I think all of these are gonna. Oh, let's see here. We do this. Put the mutator near the bottom. Okay. So let's just start stubbing this in for what we need here. Clear. Oh. Okay, so this is not as bad as I thought. It's the clear method that's gonna be awkward there. Okay. This is actually not that bad either. Since we're using other methods to do those. Okay. So we set the buffer. Do some things and then update. This is actually where things start differing. Because we only want to write out byte offset for the UTF8 character. The destructor can do exactly nothing, and that's fine. Assignment operator is a bit of a mess because of size and offset. Those are only for UTF-8. We don't need it for Latin or ASCII. The rest of this is fine. This is like one of those where it's like we've got a lot of overlap. So if we do break this up. Writer, point to right line, that. Now we need a switch case again. We're going to write something slightly different for all the cases. ASCII. I probably should keep a copy of this. It's an empty switch around. Latin1, UTF8. Almost made me feel like the AI was just throwing code at me to get me to leave you alone. That's an interesting way to think about it. I could see that. Okay, so this is only for UTF-8. If it's either of these other ones, all we want is the character offset. So allow a fall through, UTF-8 gets both. You know what, we could be even more clever. We can have everything be a fall through. This thing only writes out that and then falls through ASCII and Latin. Everybody writes that out. There we go. The power of switch statements with fall throughs. I would argue it's slightly less readable, but I'm going to put this code snippet into my scratch buffer for future use. Okay. So we write out assign the buffer. Could be a byte or a character offset or both. Then update yourself. The destructor does nothing, so let's just shorten that up. Is that what we want? Okay, assignment. A lot of this is the same. And return this. Okay. So value. So we can always write value, that's fine. That's the same across all of them. These two are going to come back to character offset. I think all of these are fine as is. Should do a straight up copy of everything. And return. Then close the function off. We can actually shorten this up just a bit. If m underscore encoding equals UTF-8. Then we write that. Then we always write that. Then we update. Although we can even shorten that up, can't we? We're going to follow a similar pattern here. This one will close up. If this is UTF-8, writer, oops, right line, Okay, let's see here. Okay. Byte offset. This is in the constructor. Oh, the update function updates byte size, so that's fine. Give ourselves an empty destructor. Assignment is we steal the value, we steal byte size and offset, and we steal all those things, which are the same across all the classes. Now we're in testing equivalence. Whew. That's why AI companies don't really let you see the system prompt behind the scenes. They're telling the model to save money for them, to be as wasteful with tokens as possible. Give them stuff that will just work, but not necessarily be correct. That is a cynical take, which may assume more evil than incompetence. And while I'm not gonna lie, there's plenty of cynicism warranted, 100%. I think that the AI is just not that good yet. I think that's why it's just kicking out so much crap. It's looked at a lot of crap code and it doesn't learn. It can't think, can't reason. It just does what it sees. I tend to blame incompetence in this case, probably. But there's both enough malevolence and stupidity to go around, so I feel like I've over indented this one. 1, 2, 3, 4. 1, 2, 3, 4. There we go. Okay. Equivalence should actually not be that bad. Yep, I'm okay with that. Or maybe I'm just being too nice. Maybe they really are that malevolent. Although that kind of genius level malevolence, I think, would require more competence than I grant them credit for. So hard to know. Like I said, I think there's going to be a lot of very sad investors here in the next couple of years. Okay, so we're through equivalence checking of that. Oh, wait a second. Not quite right. This one up here. This one down here. These two will depend a little bit on what thing we're looking at. Yeah, so this is kind of what we're going to be doing for the next couple of hours at least. We're going to grind out writing text that writing code that writes code. Well, this part is pretty straightforward where this is the code that's going to be written out, period. It does get a little bit more complex. Okay. Trying to think. These should compare with an integer or a character or something. When we're doing UTF8, we need to compare against a 4-bit value, 4-byte value. But when we're in ASCII and Latin, then we just compare with a character. In fact, the type of value will be something different. So I think we need to do something like this. If m underscore encoding equals VV project encoding UTF8. We're going to do one thing. Otherwise, we'll do something else. I think that's what we got to do here. So writer, write line. And this is dead simple. It's a return value equals other. New line and string equals. Then this update is even simpler, possibly. Because here, all we want is to take a character. Okay. We're going to have to test all of these combinations too to make sure that they work. Writer, right line. Because I guarantee you, 100%, I have forgotten a new line character somewhere. Something's not lined up properly. This thing always happens. Okay, either case, we output the same thing. We are going to. Oh, yeah. Turn. Our buffer. That's easy. Turn buffer. New line. Okay. Advance and update are kind of the bread and butter functions depending on the encoding. Where are we at? 1 o'clock. Okay, if oops, something's not closed up properly. If underscore encoding equals VV project encoding UTF8, we treat that differently from everybody else. Right line. Two, three, four. There we are. These byte size, byte offset. If I'm not mistaken, we just literally turn in underscore byte size. And byte offset. advance and toCstring are going to be different between the versions. Is valid, I think, is very straightforward, and invalid reason, and that's those. I'll just bring up here. I think we can just do these all in one shot. I'm telling you, we're going to have a bunch of mistakes to fix when we're through this. All right, is valid. Invalid reason. Invalid reason string. Easy. These are the bread and butter. Everything else we've done up until now has been kind of like, oh, do we need to keep track of bytes or not? These two are the big meaty functions that are going to make the difference. Well, in fact, this one isn't even that big of a deal. So let's do this. If no, we're going to do this. Let's do it if encoding equals we need project encoding UTF8. If it's UTF8, this is what we're going to do. Do this. It's not a thing in this case. Okay, if it's not UTF-8, we're just going to return the character. Char. Just give me a value. That's it. When we go into ASCII and Latin1, a lot of this becomes very simple. It's only UTF-8 that really complicates things. So, toCstring. Oh, we have the overridden. We can get rid of that. We simplify this quite a lot in the end. Okay, we're not doing escaped characters. I feel like something's misaligned here. If it's valid, there is no override. Otherwise, new empty string character base return result. That's basically it in here. So in this one, we have to extend it with a whole lot of extra functionality to try to make things print out nicely when we're reading escaped strings and whatnot. So a little bit more complicated. This one is going to be simple, much simpler. Quite simple, actually. So I am partially confused here. This section, okay. UTF8, okay. Here we are. I think it's all just works like that. Single right function to say, tell me how many bytes it is, plus 1. We need 2 bytes here. We had the extra byte because we were doing an escaped character. Empty string, return result. Okay. Advance, clear and update. Advance, clear and update. Again, the most complicated version is going to be UTF8. Update. We also have this. And these. Oops. Our private members. We'll do this. Whew, yeah, so we're just, because yeah, we need to generate for ASCII, Latin1, and UTF8. Those are our supported versions. Let's go ahead and in some of our private members while we're here. If we are encoding UTF8, two, three, four. Oops. There we go. And otherwise, all the rest of this stuff is common across all the encodings. Uh-oh. Power flickering. Well, shoot.